Hi and welcome to another tutorial on 2D game design in Unity. In this tutorial I'm going to show you how to make the camera follow the player with code in Unity. So at the moment if we play this game I can move around and I can go down to the end of my world, but that's it. I can't go any further. Okay, so the character is moving all the way from one side of the screen to the other. And if we have a look at the scene, there's actually a lot more there that we can explore, and I'll be adding more later. So this world will kind of keep extending. But at the moment, we can only hang around this area here. So what we need is for the camera to be able to follow the player along as the player walks through this world. Okay, and there's a few different ways that we can do it. The simplest method is just to drag the camera onto the player and make the camera a child of the player in the hierarchy. But if you do it that way, you will run into problems. So for example, you might jump up to this top platform here, and if you do that, the camera might move up higher to where the player is, and so you won't necessarily be able to see the bottom here or what's below, and so the camera will follow it will follow the position of the player on the X and the Y axis. So if you go up really high, then your camera won't be able to see what's down here because it will be all the way up here. So that's one problem. Also, if your player is not, uh, at the moment we've got a polygon collider on here, and you might have a box collider for your character or something like that. But if you've got something like a circle collider and maybe the player is a ball or something like that that rolls around, then the camera is also going to roll around and spin around, and you'll get very dizzy quickly. So that's really not the best way to do it. Okay, so I'm going to show you two ways to do it with code. I'll show the simplest method first if you really just want to get a camera on there quickly using the easiest method. And then I'll show you another method that you can use to get a really nice effect where the camera smoothly follows the player around the scene. Okay, so first thing we'll do is we'll create a script. Okay, so we'll go into the scripts folder, right click here, create C# script, and one word starting with uppercase C, camera, controller. So all one word, like that. So we've got a script here called camera controller. Okay, and now we might as well just drag it onto the main camera. That's the camera that we're using in this scene. So here it is down here. And let's double click on that to open it up in MonoDevelop. All right, and the first thing that we'll do is we need to specify what this camera is actually going to follow. And it's going to be following the player game object. So inside the class here, we can create a public game object variable, and we'll just call it player. Okay, we'll save that script and go back to Unity. And let's go to the camera, and so now we can see player here. We can just go and drag the player game object onto there. So now we're going to specify that the camera will follow this player game object. Okay, and now in the update method, we can go and add a line. Now, what I'll do is I'll show you one method. So I'll show you this. We can say transform.position equals player.transform.position. So what we're saying is make the position of the camera that this script is attached to equal to the position of the player. So if we use this method, let's just let that compile and run it, we get this blue screen. And the reason why that is because even though if we have a look at the player on the, we've got position Z value set to 0, and the main camera, its Z position is set to a negative value. All right, so it's actually in front of the player. Okay, so that all looks fine, but as soon as the game runs, it sets it to 0, which means that both the camera and the player are both on the same kind of like the same layer, so they're both together. So see how when I clicked on play, position Z value for the camera is 0, and for the player it's also 0, which means they're both in the same, they both have the same Z index, which means that if the player is on the same Z index as the camera, then the camera won't be able to see the player. Okay, so we need to fix that up. So let's go back to the code. All right, and what we'll do is we'll change this line so that transform.position is equal to new vector 3. So we've been working with vector 2s, now we're working with vector 3, which takes 3 values, x, y, and z values. So we'll say new vector 3 player.transform.position.x. So we'll get the x position of the player, and then we'll say comma. So now we've got y, so we'll say comma, transform dot position. Oops, we don't want uppercase t, we want lowercase. Transform, and if that auto corrects, just change it back to lowercase. Transform dot position dot y, and then transform dot, make sure that's lowercase as well, dot position dot z. So we've got x, y, and z. We can close that bracket and end that line with a semicolon. But what we're doing is we're making the camera follow the position of the player on the x-axis, but we're keeping it on in the same position on y and on z as it already was for the camera. So we can just save that. We can go back to Unity, let that compile, and now we can run that. And now everything looks okay. So there we go. So the camera is following the player around from left to right. If we jump, the camera doesn't move up. It still stays in the same position on the y-axis. And we don't get that blue screen. So that looks good. But the problem is, as we're moving, we can't really see very far ahead because the player is in the middle of the screen. So we can't see what's coming up ahead very far down this way, and if we go left, we also can't see what's very far ahead off that way. And you'll notice in most 2D games like this, most platformer games, if we're walking in this direction, the players are going to be over this side of the screen, so we can see what's coming ahead over on the right side. And same with when you move left, the player will sort of hang over here on the right side, so you can see what's coming over here on the left side. So what we can do is we can now use a more advanced method of having the camera follow the player, and we can set what's called an offset. So we can say that we want the camera to follow the player, but we want to the camera to go a little bit further ahead of the player, so we can see what's coming ahead. So now we can go back to the script, and we're going to set some more variables up here inside the class. So add 2 more variables. We'll make a float variable, which is going to be public, and we'll call it offset. And so this is going to be the offset for, or how far the camera is going to be away from the player. And we'll also make another variable which will be private, and this is going to be a vector 3, and it will be called player position. So what we'll do is we're finding out what the player is so that the camera can know what to follow, and then we're going to create an offset so that the camera can be a bit further ahead of the player, and then we're going to say where the position is that we need to offset, so the position of the player. Okay, so now we've got 3 variables here, and what we can do is get rid of this code here, and we're going to work with some new code in the update method. So we'll say player position equals new vector 3, and in brackets we'll say player dot transform dot position dot x, and then transform dot position dot y, and then transform dot position dot z, and close that bracket and end that line with a semicolon. So we're getting the player position, we're setting the player position to be equal to new vector 3. We're getting the player, and we're getting its x position, and then we're getting the y and z positions of the actual camera. So x position of the player, Y and Z positions of the camera. Okay, so now what we can actually do is we're going to need to set up an if statement. And we're going to check which direction the player is actually facing. So if the player is facing right, then we can kind of make the camera move be a little bit further ahead on the right side of the player. And if the player is turning and facing left, then we can make the camera move a little bit further ahead left of the player. And we can find out which way the player is actually facing by getting its local scale. Okay, so if you remember when we made the player flip, so at the moment the player can go forward facing this direction and then flip when it turns back and walks left, and we did that by working with local scale when we did our little flip animation, or working with animation, and we did the little flip for the character. So we know that its local scale on the x-axis is going to be greater than 0 if it's facing right, and if we've flipped it and it's turning left, then it's going to be less than 0. So we can use that in our if statement. All right, so that was from a previous tutorial, so if you're not sure what I'm talking about, you might want to go back to the tutorial on flipping the player. All right, so what we can say is if player.transform.local scale x is greater than 0, we need an f at the end there because this is a float. So that's a condition. Now inside curly brackets we can say if that's true, then set the player position to be equal to new vector 3 player position dot x plus offset. So we're getting the player's position and we're adding the offset now. So this camera will be a little bit to the right of the player position, and we'll specify what the offset is. We haven't actually specified what the offset is yet, but we'll do that in Unity in the moment because it's a public variable, so we can go and do that in Unity. And then we'll say player position, player position dot y, comma, player position dot z. Okay, and then we'll just have an else statement. We don't need to actually specify now, like else if player.transform.localScale.x is less than 0f, because if it's not greater than 0, then it's going to be less than 0. All right. So we just say else player position, and we don't need to say if it's equal to 0 because we don't actually need to specify what will happen if the character just comes to a stop. We only need to know if it's facing right or if it's facing left. So player position is going to be equal to new vector 3, and then basically we can just copy and paste this, close that bracket and that line with a semicolon, and copy and paste that, and now instead of adding the offset we minus the offset. Okay, and then after that we just say transform dot position is equal to player position. So we're setting the position of the camera equal to the position of the player's position, which has been set here by adding an offset. So basically move the camera a little bit to the right of the player if they're walking right or facing right, and move it a little bit left to the player if they're walking or facing left. Okay, and that's it in the code. Now we can just go back to Unity, and before we can run this, we need to go to the camera and go down to this camera controller script, and we need to actually specify what the offset is going to be. So I'm just going to make it 5 for now. Let's see what that looks like. Okay, and there we go. So you can see the player is over here to the left side of the screen when we're moving right, and then when we go to the left, the player's over this side looking left. So we've got it working like that, but it just doesn't look right. It's quite jittery. So the camera kind of jumps. So if we're going this direction, the player kind of jumps over here, and it's very jittery, so it's not very smooth. So what we can do now is make the camera actually smoothly go from left to right when the player changes direction. All right, so we're going to have to change the code just a little bit. So let's go back to the code again, and we're going to have to change this line after the else statement there. So let's delete what we just added, and this time what we'll say is transform.position equals vector3. We don't need to say new vector3. We just say vector3 dot lerp, and basically we use a lerp to smoothly move the camera into the right position. And when we add the first bracket here, we've got 3 values here. We've got vector3 from, vector3 to, and then float. So vector3 from is where the camera currently is. Vector3 to is where we want the camera to go to. And the float value is going to be how much time it will take to get from point A to point B. Okay, so for the first value, we can say transform.position. For the second value, we can say player position, because we want the camera to go from the transform position to the player position. And then what we need to do now is actually we need to create a new variable. So let's go back up to the class here before we continue. And we're going to create a new variable called public float offset smoothing. Okay, so we're going to specify basically how much time it takes for the camera to move from one side to the other side, rather than just moving instantly. Okay, so it will gradually move over time. So we can say offset smoothing, and we can specify this value in Unity. It's a public variable, so we can specify that when we go back to Unity at the moment. But what we want to do is, rather than just saying this, we can say multiply that by time dot delta time. Close that bracket and end that line with a semicolon. And what that will do, by using time dot delta time, that's going to maintain smoothness no matter what computer this is going to be played on, and no matter what frame rate it will be rendered at. So it'll be smooth no matter what, if it's a slow performing computer that's going to make it really slow or reduce the frame rate, or whether it's a really fast, well performing computer. It will maintain smoothness no matter what. Okay, so we'll save that code, go back to Unity, and now we need to add, we've got the offset, now we've got offset smoothing here, so we need to specify what that is. I'm going to set it to a default of 2, and let's go and play that. And now we can see when I switch from moving right to moving left and back and forth, the camera is much smoother now. So instead of jumping from one side to the other, it slowly moves back and forth like that. And we can change the value. So we could make it, if we wanted to move it faster, we can make it maybe 3 or 4 or 5 or something like that. So I'll change it to 3. And now it moves really quickly, like that. We can make it something really slow, like maybe 0.5. And so now the camera is really kind of smoothly following it, slowly catching up. So that's really smooth. So you just need to make it whatever you feel works best with your game. I'm going to set this back to 2 and leave it at that. One last thing I'll mention is that if you have a look at your player when the player's moving, if the player kind of looks really jittery as it's moving, like the animation looks really jittery, what you can do to fix that is go to your player and go to the rigid body 2D component, and where it says interpolate, at the moment it's set to none. You can fiddle around with that. So you can set it to extrapolate or interpolate and just see what works best. I'm going to set this to extrapolate, and now you might see that the player is not so jittery. The animation is a little bit smoother, looks really good. So that's just one tip, just in case you find that if the player animation or your sprite that you're using is a bit jittery. That's basically it. So that's how to get the camera to follow your player with code in Unity. Thanks for watching.